This demonstration will focus on a completely malware-free attack on a Windows Server environment. We will start by exploiting a web server to establish remote access. Then we will walk along the kill chain and perform reconnaissance, credential theft, lateral movement, exfiltration, and ultimately achieve persistence. All steps will be done without using traditional malware. The environment consists of two machines. The first is a Windows 2008 R2 server running IIS and SQL Server. That machine is in the bottom right corner of the screen. It's serving up a very basic form-based web page, visible in the bottom left corner, that posts unsanitized form data into a SQL Server query. The web server is connected to a domain controller running Windows 2012 R2, which you can see physically in the top right-hand corner. Both machines are running Falcon Host, which will allow us to detect and understand all the malicious activity performed. The Falcon Host interface will be visible in the top left-hand corner. We'll start by using a SQL injection attack to install the Chopper web shell. We do this by echoing a text file into the web server's application directory. The Chopper web shell is notable for its concise size and stealthy nature. It's only 72 characters and its execution is hidden inside the context of the web server. You can see when we post the command, the webshell.aspx file is created on the web server. The web shell is accessed remotely by using a GUI client that includes features like a file browser and a remote shell. We'll start our reconnaissance by opening up that remote shell and running some built-in system commands to learn more about our target environment. The whoami command shows that the web server process is already running as an elevated local system user, so we don't need to worry about privilege escalation. This configuration is more common than most people realize. For example, the default configuration for Exchange's Outlook web access app uses a local system account. Next, we'll use the system info command to discover the name of the domain the web server is connected to. The domain is called victimnet, and we can pass that information along to the netdom command to discover the name of the domain controller it's connected to. This will be our target later on for lateral movement. Let's pause the attack momentarily and log into the Falcon Host cloud-based interface to see what's been picked up so far. Drilling into the detection screen, we can see that our web server, IIS1, has already been flagged for suspicious activity. Opening up the alert itself presents us with a list of specific indicators of attack, or IOAs, that were triggered. This includes command prompts and recon tools spawning under the IIS worker process, as well as command line patterns indicative of the unique way that Chopper passes commands from the GUI to the web server. We also can see a process tree that exposes real-time forensic data at a per-process level. Next, I'll switch back to the Chopper GUI and perform some credential theft. Instead of writing some sort of password dumping utility to the server, which could be easily detected by AV or blocked by whitelisting, I'll use a single line of PowerShell. This command downloads a remote script directly into memory, injects into the LSAS process, and dumps out any cached credentials in plain text. We're in luck and are able to get the password for Tywin L, a domain admin. We'll quickly switch back to Falcon and refresh our alert. We can see a new IOA has been triggered for credential theft, specifically that the LSAS process was accessed by PowerShell. We can also see some additional details about PowerShell, including its command line and the fact that it made remote network connections and performed some DNS lookups. Back to the attack. Now that we have admin creds, we can get ready to pivot over to the domain controller. I want to maintain my stealthiness and avoid generating activity that could be easily spotted, so we'll use a technique known colloquially as the sticky keys or the on-screen keyboard login bypass trick. We accomplish this by passing our credentials via WMIC, another built-in Windows function, and remotely modifying one line in the domain controller's registry. Specifically, we're telling the on-screen keyboard process, OSK, to operate in debugger mode. Before we activate the login bypass, we'll verify that the behavior was flagged. A new alert for our domain controller, DC1, has been generated. Forensically, we can see that the WMIC service modified a line in the registry to achieve persistence and bypass login security. Now let's activate the bypass. We do this by launching a remote desktop connection to the DC. At the logon screen, we'll launch the on-screen keyboard. Only instead of a keyboard, we're presented with a command prompt running as an elevated system account. Not only does this allow us to bypass login security and standard event logging, but we also get some free privilege escalation. With these elevated privileges, we can use the VSS admin tool to create a shadow copy of the hard drive. The reason for doing this is that we can now access the encrypted Active Directory database file as well as the decryption keys. Once we exfiltrate these files, we can crack the database offline to get the name of every machine, user account, and password hash for the entire domain. This allows for the use of some devastating tactics, such as the creation of a golden ticket, which allows persistent access across the domain for up to 10 years. However, I'll omit that portion from this demo in the interest of time. I've copied the relevant files to the domain controller's root drive, and we'll come back to them momentarily. Refreshing the Falcon UI, we can see a new alert for both the use of the keyboard bypass trick as well as the theft of the Active Directory database via a volume shadow snapshot. To finish up the attack, we'll hop back to the Chopper GUI and use our stolen credentials to mount the domain controller's drive as a network share accessible via the web server. Then I'll copy our files to the web server directly. Finally, we'll make use of Chopper's file browser to download these files locally. We'll wrap up the demo by going back to the original web shell detection on our web server. We can see all the other activity performed, including the use of WMIC to remotely interact with the domain controller, as well as the Active Directory database files being accessed by Chopper via the web server worker process.